Okay, in the last video we learned how to balance redox reactions under acidic conditions. Let's try one under basic conditions. And what I'm going to tell you is, originally in the notes I wrote a little asterisk next to the one that was basic conditions. Here's the little asterisk. It's actually significantly easier to assume that it's acidic conditions and then just fix it at the end. And I'll show you how to do that in a sec. Okay, so the reaction we want to balance is Br2 forms Br minus plus BrO3 minus. Okay? Well, you see we only have one reactant, so presumably it's going to be the reactant for both sides. So for both half reactions. So one half reaction is Br2 becoming Br minus. The other half reaction is Br2 becoming BrO3 minus. And we're just going to balance these under acidic conditions and assume that everything's fine. Okay? So, first things first for this half reaction is we got to balance the bromines. We have 2 on this side, 1 on this side, so we need a 2 in the front. Okay? We don't actually need to put any waters because there's no oxygens, there's no hydrogens. We don't need to deal with any of that. The only thing we need to deal with now is the charges. This side is -2, this side's 0, so we're going to need 2 electrons over here to make this side add up to -2. Okay? For this half reaction, we have a Br2 and this is a BrO3, but there's only one Br, so we need a 2 in the front. Okay? This gives us 3 oxygens times 2 would be 6, so we need 6 waters to cancel that out. Okay? 6 waters will give us 12 hydrogens, so we need 12 H pluses on this side. Okay? Now we need to balance the charges. This side adds up to 0. This side is 12 minus 2, should be 10 electrons, or a plus 10 charge. So we need 10 electrons on this side to get it down to 0, which is the lower of the 2 numbers. Okay, a little messy, but not too bad. To cancel out the electrons so that we can combine these reactions, this one has 10, this one has 2, the least common multiple is 10, so this one's good. We need to take everything in here times 5. Okay? So, the electrons will cancel out. 5 times 2 would be 10, this is 10, so I'm not even going to write them. But we're going to write everything else. So 5 Br2s plus this Br2 would be 6 Br2s. And then we have 6 waters from this reaction. We have 5 times 2 Br minuses, so that's 10 Br minuses. And then this one we don't need to scale up, so it's plus 2 BrO3 minus plus 12 H plus. Okay. Technically speaking, everything here is divisible by 2, which means we can reduce this. I'm just going to go ahead and do that now so I don't have to think about it. You don't always have to do this, but in this particular case, it works out. It reduces the equation, and it actually probably will make it easier to see what's going on. So everything divided by 2. So this is 3 Br2 plus 3 waters forms 5 Br minus plus BrO3 minus plus 6H plus. Okay. Hopefully not too bad so far. Technically speaking, this would be balanced. Okay. We have 6 Brs, 5 plus 1 would be 6. We have 6 hydrogens, 3 oxygens, 3 oxygens. This side adds up to 0, and this is 6 minus 1 minus 5 would also be 0. So everything's balanced. The only problem right now is this is acidic. So what we're going to have to do is convert it to basic. So when you need to convert things to basic, because it's supposed to be basic at the end and we've been assuming it's acidic, it's honestly not that difficult. What you do is anywhere you see an H+, which should only be on one side at this point, if there were other H pluses up here, they would have canceled out. Just add that many OH minuses to both sides. Okay? H plus and OH minus neutralize each other, but they don't cancel out. This, H plus OH, makes water. So you end up with 6 waters. Okay? And for canceling out purposes, we have 6 waters on this side and 3 on this side. So I'm going to cancel this out, and this will become a 3. So I'm going to rewrite everything so it's at least a little bit pretty. So I guess this kind of goes away and becomes those waters. So we have 3Br2 plus 6OH minus forms 5Br minus plus BrO3 minus plus 3 waters. And if I didn't mess anything up, this should be balanced and it should be basic. We know it's basic because there's only waters and H2Os other than the original atoms that we started with. Okay, so it's definitely basic. In terms of balancing, we have 6 bromines, 5 plus 1 is 6. We have 6 hydrogens, We have 6 oxygens, there's 3 and another 3 would be 6. The charges, this side is 6 times -1, this side's overall -1. I guess I can write that one. Or, well, let's do it this way, -6. This side we have -5 and -1 is -6. So everything's technically balanced and it's basic at the end. So the reason we do it this way, the reason we wait until we do it acidic and then fix it at the end, is that it's really difficult at any given moment. Like if you had 3 oxygens, do you add 3 OHs or do you add 3 waters? Or 6 waters? Or sorry, there's 6 oxygens. Do we cancel that out by adding 6 waters or 6 OH minuses? There's no easy, good, consistent way to tell. So under acidic conditions, it's really clear cut. Like if you need oxygens, water is the only option. If you need to cancel out hydrogens, H plus is the only option. And then converting it at the end, I don't know, seems simpler to me. It's simpler than having to like trial and error your way through it. Okay, all right, thank you.